Hey everyone, so welcome to this workshop. The idea for this particular workshop is to discuss how to implement multiplayer experiences. In particular, in this case, we're going to use the message bus to create them. In particular, we are going to try to build a multiplayer pixel wall. You might have seen examples of these pixel walls in the Pixel Chain Gallery, in the Soho Plaza, on many other places. So basically, we're gonna have a wall, and we're gonna have the ability to paint each pixel or tile with a different color. And we're also going to have a palette, so you can select the colors you want to paint the wall with. All this is going to be multiplayer. That is, everybody who is on the same scene will be the tiles changing. Will see the tiles changing, and I think that's it. I mean, I just want to mention a few things. So first, um, we are going again. We're gonna use the message pass. This scene in particular is based on this other example scene. This is the one that is actually used in the pixel chain gallery. There are a few differences. We're gonna be making our wall a little bit smaller, just so that it loads faster. And we're, we're going to mention how to also make it bigger, but we're not gonna do it in this case. We're also not going to send the wall itself to the blockchain, to the pixel chain smart contract. That's a whole different subject. And in the other example scene, when you changed the color on the palette, you would also see it reflected on the wall. We're not gonna do that here, and mainly because that was a limitation for the pixel chain smart contract. Since we don't have that limitation here, we're going to allow a lot of different colors to be used. One other thing to mention is that, I mean, this is fairly a complex experience we want to build. I'm going to assume that you know the basics for the SDK. You know a little bit of JavaScript, um, and I'm gonna build it in a way that maybe it's not the best, but I just want to make it as clear as possible for everybody to understand. When you build experiences that are as complicated as this one, there are, of course, a lot of ways to build it. I'm not saying that this is the best. Whatever you think is better for you, and as long as it works, then that's okay. But I just wanted to bring that up. Okay, so what I'm going to do first is I'm going to explain a little bit about the theory behind what we're trying to do and explain exactly what we want to achieve. So maybe if you're seeing this in a recording, you can try to do it by yourself first, and then we're gonna start working on it. Okay, so let's dive right in. So when you have, I mean, there are mainly two different options to build multiplayer experiences. The first one would be a client server, when where you have a server that's running somewhere, and all the different users that enter that scene will connect to that server. And on the other way would be to have a peer-to-peer network. In that case, all peers will connect to each other to let each other know what changes happened. And so the message bus basically focuses on the second one, on the peer-to-peer network. And basically, it's like an abstraction of the communication between all peers in the same scene. So how does the message bus work? So let's say that this peer generates a change. In our case, it could be like it paints a specific pixel or tile on the wall. So it's going to send this update to the peers it's connected to, and each of them is going to then send that same update to the other peers that they are connected to. It's important to know that, in this case, you see like everybody's connected to everybody. That's not the case actually, because there's a limit on how many WebSocket connections the browser can have. So in our case, it's more or less like this. When you are connected to a number of peers, and then updates just get broadcasted through the network. So it's important also to mention the limitations. I mean, if if your updates could take a while to reach the other players or users on the scene, and this is mainly why, because it has to propagate through other peers. So okay, now we kind of understand what the message bus is. This is basically how you use it. So when you have an instance of the message bus, you can send a message. You set a message ID and then a payload that this could be whatever you want to send. When you execute this code, then all the other players that are listening to this message ID will receive this payload. So how to listen to these messages? Okay, so you can also take an instance of the message bus. You write .on, and you say, okay, when I get a message with this ID, then execute this function. This function will receive the payload, that is the same object that was sent, and the sender, that is the person who sent it. Basically, with these two things, you have everything you need to communicate with other peers and try to build multiplayer experiences. So what should we send through this message bus? There are mainly two things that we will try to send. First is the current state. For example, when I'm loading the scene, I want to know exactly what everybody else is seeing. So I'm going to ask, hey, what are the colors on the whole wall? And somebody's going to have to send it to me. And also changes that happen through time. I mean, once I'm already connected, when each time a tile changes color, then we're also want to update that to everybody else. So let's see exactly how it be. So let's say I have a user that's already in the scene, and there comes a new user that enters the same scene. So it will ask, using the message bus, it will ask to everybody else what the current state is, and then the users that are already on the scene will let them know what the state is. And the other case would be like, okay, both are already on the scene, both are already in sync. So if the first user makes a change, it will notice the second one, and the second one will get that change and update it on their screen. And that's mostly it. I mean, with these few concepts, we can build this experience. So let's go ahead and try to see if we can build it. So what I'm going to do, I'm going to start from scratch. I'm going to create a new folder. I'm going to enter the folder, and let me just to make sure everybody can read it. And I'm going to run DCL init. That will download and create everything. I'm going to use Visual Studio Code. Let me open a new window. Workshop. That's it. There we go. Okay, so I basically have a scene already. If I run DCL start, I'll see that the client's here. It's gonna load, And there we go. We have this basic scene. Okay, so it's working. Great. First, I'm gonna install a new version of the SDK. This is because we have a few bug fixes that will be going out in next following days, but I just want to use them right now. So I'm gonna just install the latest version. I mean, the newest version. And let's go into code. And here we go. Okay, so this is the scene, the example scene that is added when you create a new scene. Let's delete it. Okay, let's start. Let's say with the palette. Let's create a new folder. Let's call it entities, and entities we will create a new one for palette. And on here we're gonna create palette. Yes. Okay. So let's create. I mean, maybe you'll realize, maybe you won't, but I have a background on Java, so I tend to write things as if it were Java, but I'm more or less starting to get more acquainted with TypeScript. But let's create this palette. Sorry. Let's say it's an entity. Okay, so when we build, let's do this. Okay, so now from here, we can create the palette. We can actually like to do this in here just so I forgot. I mean, if I forget here, then that's okay because this is already doing it. And here, let's see how it looks. If I had stopped this, if I go to the browser, it's going to start again. I mean, I haven't done like nothing yet, just want to make sure. Great, exactly, still working. Okay, so let's start adding some colors to this. We can add this a plane shape, and we will also give this a color. Let's do the following. So I'm going to go in here, create a new file, materials ts. I'm going to create a function that it's build material given a color. Why am I doing this? Because I'm going to change colors in both the palette and the wall. So I'm going to just have a function here that returns a material. I think that would be the best. And I'll create a new material here. I think it was, let's check the documentation, how it was done here. I actually like to rely on the documentation a lot. It's just easier. It's like our own version of Stack Overflow. And from hex string. So, okay, so this is going to be a hex string. Let's do the following. Export type color is one string. Color hex. And because I'm pretty sure I'm going to use it a lot, it's on my material. Okay, so from now here, I can now add this material. Oh, forgot to export. Export it. Great. So I think we wanted to go with the brown. Yeah. So let's see how it goes. Okay, there it is. But it's way off the scene, so let's move it a little bit. And let's go to game, the component, new transform, and here we're going to set the position. Vector 3. Let's put it on the Okay, so that should be putting on the middle in the scene. Let's continue. So, okay, so now we have a palette. Let's add the different swatches to it. Let's do the following. Let's create another class that it's called swatch. Export class swatch. This is also an entity. And if we go back to this, we wanted to have, in this example, we have 16 different colors. So, okay, let's do that. We'll have 16 of these. So the palette will contain a few swatches. And we will have an array of arrays because this has rows and columns. Again, you can just have an array, but I'm just going ahead with this. No, this is completely a personal decision, right? So let's try to fill it. When we build this palette, we can fill each one. We can create each one of these swatches. So we said that we will have a 4x4. Then with swatches E, we'll create also this array, just we don't get an error next. And position, we'll create this object that contains the row and column. And then let's just create the swatch here. And then maybe we can set the color for it. I mean, of course, we haven't built that, but we will pass the color, and then we will assign swatch. Okay. And I think, oh, right, before I forget, set parent this. Okay, so basically we're now creating these swatches, we are assigning a color, and so when we finish building this palette, we will have, it will be full with all these swatches. Let me use my cheat sheet. These are the colors that we are using for default. Let's import this color hex. So let's set default colors. Okay, great. So, okay, let's try to build a swatch now. Here it is. So far nothing done yet. Of course, since we need to call super because we are extending from entity. And let's receive the position here. We said that this was going to be a position. So I like to create types for everything, just to make it clear on the code. This is a number, another number, so we will receive this position. And we also said that set color, we will receive a color hex. And when we get the color, we will add or replace build material color. Okay, so we need to use this position to assign it. Let me also use my cheat sheet. This is just what I'm doing here is I'm deciding, depending on the position, the row and the column, I'm assigning an X and Y. This was just, I tried a few, these numbers, I know they sound magical, but I tried a few numbers and these were the ones that I liked the most. I'm using this cheat sheet just so you don't see me trying different numbers to see what I like the most. But basically, yeah, you need to go ahead and try it, see how it works for you, modify numbers or the way you calculate them, and see what works for you. So if I go now, let me check. Something's failing. Okay, yeah, into. Okay, so it's weird that it isn't loading. Okay, so we have this palette. Oh, right, I forgot. Let's set it up a little bit. And also we forgot engine, I'm going to add this. Hey, so where are the palettes? Okay, so where are the swatches actually? It's in constructor, set parent. So that's setting the entity. Oh, right, my bad. I forgot to add the shape. Component, new plane shape. And there we go. Okay, so that's a little dark, right? So let's go ahead and the materials. Let's change this. Let's see how it is. Okay, that's nice. Okay, so we now basically have a palette and with different colors, with different swatches. That's great. Now let's add like some behavior, right? So what do we want? We want that when we want to first be able to select this, but then to be able to change the color. Since we haven't built the wall yet, let's just go ahead and change the color. So I'm gonna increase. Maybe it's a little too late. Okay, great. So let's add the component, new pointer down. So what do we want to do? So when we click it, we want to, let's add some, sorry, my bad. Okay, so let's say change color. And the button will be, I don't know, for now it can be the action primary, maybe? Yeah, sure, for now. So what do we want to do now? When we click on it, we want to grant the ability to users to change the color. And for that, let's use the new UI library. This is just fresh new. Let's go ahead and install it. Oh, sorry, Decentraland. That was the wrong version. Utils. Okay, here it is. This is how to install it. Then I go here, go ahead and install it. That's great. And I think it was called prompt. Option fill-in prompt. Okay, great. This is exactly what we want. Let's add this here, for example. This is how to import it. It's important that you read the full documentation. But we are a little bit, there we go. So let's say we want to write here, select a new color, change, and okay, so this will be the placeholder. So let's do the following: private color hex. I mean, let's just see how it works right now. Let's start the scene again. Great, so if I press E, here I see the text. So I would like to instead save the previous color so I can use it. This color, and we will use the placeholder as the current color. And once we change this color, we will const new color, want text, we'll remove some spaces, and this set color, new color. Okay, right, so this should work, but it won't. Mainly because there is an extra line break that is added to detect that it's not removed by trim. So we'll basically do a sort of hack and remove it manually. So now let's try it again. I know this is, I mean, the problem is it's a special line break that it's added. So we need to remove it like that. So if I go here and click change color and write click change, then the color is changed. Nice. Okay, so we now have a working palette with different swatches. Let's try to see if we can make it multiplayer. Because right now, if two users are on the same scene, and one changes the color, then the other won't be able to see it. So let's try to do that. Let's go back a little bit to what we said that that we needed to do. So basically, we need to do two things, like share the current state for people when enter the scene, and then share changes that happen through time. So let's go back to our code. I'll create a new here called multiplayer entity. And this will be an abstract class. Abstract class multiplayer entity. And this is an entity. Okay, so we're trying to define what a multiplayer entity should do, because we will have two of them. One would be the palette and the other one will be the wall. So let's say I create, multiplayer entities should be able to react to single changes. And here we will get that change. They should also be able to react to or load a full state. And also they should be able to provide the full state. So what the change will be and what the full state will be would depend on the entity itself. So let's create these types: single change and full state. I'm sorry, but I love types. They make my life a little bit easier. Okay, so basically, multiplayer entities will need to react to single changes. Given a change, they will need to update themselves somehow. Given a full state, they will need to, again, load that full state, and then also provide a full state. So when other users need to ask for this, they are able to return it. So let's do a little bit more. Let's create a message pass. New message pass. We also need to, because this is an entity, and let's kind of create a protocol, and let's call we will handle three types of messages. One will be requesting the full state, one will be returning the full state, and the other one will be alerting of new changes. So let's do just that. Let's call one full state request, full state request, full state response, and then single change event. single change event. Okay, so what we'll try to do first is let's listen to these changes. So as we said before, when somebody asks for a full state change, payload and the sender. There it goes. Then we also need to listen to message bus on full state single change event. So when somebody announces that something happened, we need to listen to it. What's wrong here? Oh, there. My bad. Okay, so let's say when somebody sends us, we listen to a single change, we will call this .react to single changes, and we'll send this here. First, we need to make sure sender, because one thing to take into account is that the message bus, you will listen to your own messages. So just to make sure that we don't react to our own changes. Payload here. So basically, when we hear that something changed, we try to react to it. That's basically it. And when we have somebody ask for the request, again, make sure that it's not us. And one thing we need to take into account is that, let's say that we enter a scene, we request the full state, but we still have no answer. If somebody else then comes after me and asks for the full state, we don't want to send them what we think it is, because we still haven't heard. I mean, we still don't know what the full state is. So let's add initialized. Let's do this. For example, we know that we haven't initialized yet, so we will. If we haven't initialized, then we won't respond to this request. But if we are initialized and we didn't ask for it, then let's just return it full state. So provide full state. And then let's just send it message bus .emit and this full state response. And we will send the full state. Yeah, we didn't need the payload actually. Okay, so this is pretty good. I mean, right now, just to recap what we did so far, when somebody asks for the full state, if we have it, we'll send it to them. And when somebody sends us a single change, then we will react to it. So far, so good. Let's just do one more thing. That is, let's create a method that's called start, or yeah, let's call it start for now. Basically, what we want to do here is that we want to request the full state from everybody else and load. We could potentially do that here, but we will separate it. The main reason to separate it is because maybe you want to wait until you enter the scene to actually start messaging everybody, or maybe you want to wait until you enter a specific part of your scene. I mean, this all obviously just depends on what you want to do, but that's just mainly why we want to create a new method for it, so each person can start singing when they want to. So okay, so basically when I start singing, then when I want to request the full state, let's just do just that. Message pass.emit saying I want the full state, nothing to send in particular. And then we need to we would like to set a timeout. I mean, let's assume that what happens if I'm the only person that just entered the scene? There is nobody else. Then nobody's going to actually respond to my request. So after a while, I want to give up and say, okay, maybe there's nobody else. So the defaults are going to be okay. So we're going to write something called, set timeout. How can we build this set timeout? Let's do the following. Let's create a new file, utils, and we will use the utils library. It has a delay component. So let's see how we can install it. Great. So that's installed. We said delay, right? This is just to make it easier for me. Delay, that's a number, and a callback. That's a function, doesn't return anything. Oh, sorry, my bad. And we'll do this. We'll create a new entity. We'll add the delay. Sorry, I forgot to include it. And when this happens, we call the callback, and we will engine.remove the entity. Okay, does this make sense? So basically, we will add a component that will wait for this amount of time. When that amount of time is reached, we will call for whatever we provide here, and we will remove the entity that we added. So basically, by doing this, I can just go here and use this set timeout. Let's say after 5 seconds, I will give up. Give up waiting for response. And just say, okay, let's just set this .initialize is true. I mean, if after 5 seconds I didn't get a response, then I'm gonna consider myself initialized because nobody else on the scene. Okay, so one more thing is this is request full state, and what we need to do now is react to the full state, right? So message bus dot on response, I'll get the full state here, and if I'm not initialized, then I'm going to first consider myself initialized, and then I'm going to load the full state. Load the full state. Does this make sense? I mean, I'm waiting for the response, and when I hear it, if I'm still not initialized, then I'm going to just load it. I think that with this should be, I mean, this is already pretty good. One thing we need to take into account is this particular method. So basically, when we request the full state, we are going to send a message requesting it. Now, it could be possible that for different reasons, that message is lost. So we're going to try a few times until we give up. So let's create a method. Sorry. We'll call this request full state. And what we will do is that after we request it, we will wait a second and request it again. Okay, does this make sense? The only thing we need to take into account is that if we were answered, we want to stop requesting the full state, because as this is right now, we wouldn't finish. So if this initialized, if I'm not initialized, then request the full state. Okay, does it make sense? So basically, when I start, I request the full state. If I'm not initialized, I will request it and wait a second and request it again. After that second, I'll check again. If I'm not initialized, I'll send them the same message and again until I'm initialized. And that could be that I got the response or that I gave up. Okay? Maybe this will work. Let's see. Now let's go to our palette, and let's, instead of extending from entity for multiplayer, okay, so now I need to define these two types. The first one was a single change. So let's create a type, because as I said, I love types. Palette change, and this is a swatch position and a color. Okay, so how will we will be communicating changes by sending the position of the swatch that changed and the color, and then the full the full change will, I mean the full state will just these this arrays of colors, just like we did here. So I implement these methods. Let's put them here. Okay, so basically, in this case, how do I react to a single change? Okay, so I can, sorry, position, color. So I can this swatch position I, position j, dot set color. Okay, so basically what I'm doing here is that when I get a single change, when a single change, I just change that swatch. Let's say I get a full state. I will, pretty similar to what we did here. I mean, we don't have to do this. This is color. This is color. I'll let's do it like this. Okay, so what I'm doing here is I get this full state, and I'll go through every one of these swatches and set the color for it. That's pretty much all I have to do. And to provide the full state, I'll do more or less the same as here. I'll create a result that has this type. I'll need to instantiate it here, and we need to learn the color of these, these swatches. Get color. Salt. And then just return. Does this make sense? So I'm going through every one of these swatches, collecting their colors onto this variable and just return it. So now I have to implement it. I can implement it here. Let's make this public. Color hex is return this color. Okay. Does it make sense? So basically we are providing full state, loading the full state, reacting to single changes. Let's see if this loads. I think it stopped it, right? Yeah. Okay, so at least it loads. But there is one thing that we still need to do, and that's when we change the color, we need to somehow communicate it, because right now we're just changing the color here, so we're not sending it through the message bus. So let's just create perform change. And we will generate this, react to the change, and send the change, like single change event and change. Okay, so basically we are here letting everybody else know. Here we're react to. We could avoid this here and just do it somewhere else. Besides calling perform change, we could also just react to it. I don't know, just personal opinion. So basically now I need, when here we're setting the new color, and now we need to you know what? Let's remove it for now. And then let communicate. Okay, change. Okay, so the swatch itself doesn't know anything about the message pass, but we can change listener, that this will take the new color. So basically when this changes, new color. Now when I create this, the new color, we will just call this I don't like this name so much. Let's propagate. Yeah, I like it better. And this needed change, and we said that change was a position and a color. So position, color. Okay, so let's see how it works. If I change this, okay, so this got changed. That's great. Let's create a new window. Remind that you have to use different windows. I mean, if you use the same window with different tabs, it won't work. But now, as I enter the scene, oh, okay, so my bad. If we remember correctly, I mean, we can see that we see the other player there, but we haven't synced yet. So if we remember, we defined this start, but we never called it. So let's call it here, start. And so let's say change this. Sorry, my bad. Forgot. Okay, so you see that this was, I mean, if I change this other one, you see that both get in sync. So let's just try one more thing. Let's reload it and see if the new one gets the full state when they load the scene. Yeah, that's it. I mean, we did it. So now, when we perform a change, the other one sees it, and when you enter the scene, you get the same full state. Great. So now we basically have a multiplayer experience. I honestly thought that we would have an error or something. That was pretty great. Okay, so this is the palette. And let's try to quickly do the wall. It will be pretty much the same. Okay, so let's rename this, just so you see that we can use the same idea twice. This will be the wall, and this will be each tile, let's call it. Pixel is kind of, and let's call this wall. We have tiles. Let's so define it. What is a tile? We will have we will also have positions, but will we tile positions? Maybe we could also have just one type position, but I don't know. This is what we're doing. The listener, I'm not sure exactly how we will do that yet. Let me use my cheat sheet. I have these variables. I like to use config ts and just define this so we can change it later. So basically I'm changing the wall size. It will be 10 by 10. Each tile will, the size will have, and how much space to have between each tile. So let's just import this. Again, these are all numbers and things that you will need to try for on your own and see how it works and if it works for you and if you like it or not. And let's add this transform. We'll here need to use a box shape, not a plane shape. And on pointer down, okay, we'll get to it. When we click on it, we want to paint it. And we'll add the entity. And what else? What else? We can choose a starting color. Let's go to our config, export, start, circular hex. Let's start with all white. Start, yeah. Maybe that's it. Let's go to the wall. We have tiles here. The wall itself doesn't have any shape. Let's call these tiles. We said wall size, new tile. Let's also call this tile. We already have a default color, and so that's okay. When we react to single changes, we just change the color. When we load the full state, again, we just set the color for each tile, and we provide the full state. It's more or less the same. This will be wall change, style position. So as you can see, I mean, these are more or less the same. It's the same idea, right? So you have children. It used to be swatches, now they are tiles. When you click on it, you have to propagate the change. When you have to react to changes, in this case, again, we're just reacting to different colors, etc. So again, let's add the wall, how do we call it? Yeah, well, we will add the wall. Let's move it a little bit to the left. Wall. Okay, so I think we paused it, right? So let's load it again. Okay, so we have, there it goes. So one side we have the palette here, and then we have the wall. The wall is a little bit closer to the ground. And what we need to do now is when we click on the wall, we need to make sure that that your paint it is paint with the current color. So let's go here, create something called global for class global static public current color hex. It starts with a star color, and basically we will paint. Let's go back to the tile. We will paint this set color with the current color. Okay. Let's import it, and also we will alert the listener. We will change the color and we will propagate the change. Okay, does that make sense? And the other thing to do here is let's try it first, right? Instead of okay, right. So when I click on it, then the color changes and it should be propagated to other users. We will try that. But what we need to do now is that when we also need to, instead of just changing the color here, we need to also select a color, right? So let's do that. Swatch here. We need to do two things, right? So here, we will need, with E, we will pick a color, and with F, we will change the swatch. We will use any, and here you can get the button ID. And if the button ID is 1, then you pick the color. But if the button ID is 2, then you change the color. Okay, this is just so we can have these two different behaviors. Change the color. So what we need to do now is we will change the current color to the color we have right now. Okay, does this make sense? Let's try it. We will have two different windows again. Let me start. Okay, so I can select the color. Great. That seems to be working. And now if I enter here, let's see if I get the full state. Oh. Oh, I know what happened. Okay, so something happened. And this is something I left for later. We need to try it now. So basically, when we do a full state request for each entity, when we do a full request for the wall, we got the full state response for the palette. So we need to somehow differentiate the requests between the wall and the palette. So basically, we will add an entity type. Let's call it like that. Private read-only. And let's create generate message ID with a message name. What we're doing here is we're going to create two different messages. One for the wall and the other for the palette. Okay, so basically the wall would say to I'm a wall. So basically when you come here, the message you will be listening is wall/full request. Okay, so here you will be listening to wall/single change event. That's basically what we're doing, just so we can differentiate the communication in between the different entities. I think that's it, right? 1, 2, 3, 1, 2. Yep. I think that's it. And here, okay, so let's try again. And if I load here, interesting. Okay, so I knew at some point we'll have the full state. I knew at some point we'll have to see. Let's see first if, okay, yeah. So the problem is loading the problem seems to be loading just the initial state. Let's see. Okay, so we'll need to add some logs to try to see what the problem is. But that's okay. I mean, it's part of it. If everything just worked, I mean, that doesn't happen in real life, right? So let's do this. Request full state. Oh, I know. Here. I had forgotten to add the entity type to this response, so no one was listening to that. Let's see if it works again. Here, is here, and also let's change this to this. Okay, so let's try to load this here and see if I can get the full state for both the wall and the palette. Okay, so I got it here, but I didn't get it here. Oh, I think I know what happened. I forgot to So this is what happens when you copy paste. Okay, so my bad there. Let's try it one more time. The third time is the charm, right? Then let's load this again. Okay, that's it, right? Seems to be working. Let's try some real-time changes. Seems to be working. Let's try this way. Palette. Change the swatch. Yeah, it worked. Okay, so basically we now have a multiplayer experience. We have both the wall and the palette both sync when the scene loads. Both sync when changes happen, and you can just select whatever color you want here and paint it here. So that's it. The only thing left that I wanted to mention is that, um, as I said before, the we chose a 10 by 10 size because it loads much faster. If you check the example scene that I mentioned earlier, you will see that I think it's 32 by 32. So basically what we did there, just so you understand if you take a look at the code, we had to split the loading into different parts. One was, first we added all the information about position and behavior and other stuff. Then when you entered a specific trigger, you would start loading or asking everybody for the full state and update the colors. But but only after you entered a third trigger, you would actually show everything. So by splitting the process of loading into different steps, and the wall would be loading behind the scenes. So because if you try to do everything at the same time, you will get a lot of lag. So we had to do that. Just wanted to mention that. So if you want to build a wall that's a little bit bigger, you know how we did it. Okay, and I guess that's it. If you have any questions, just ping us on Discord. Bye, guys.